Hello and welcome to the session on types of numbers. In this session, we'll understand the classification of numbers. We'll understand the difference between integers and decimals. And finally, we'll also see what are rational and irrational numbers. So let's get started. The modern system of numbers dates back only a few hundred years. Does it mean that in ancient times, people did not use maths? Well, they did. But obviously, they did it without realizing that they were using maths. For instance, then the monetary system was not prevalent, which means the system of currency was not prevalent. So, how did people trade? They used what we call the barter system, which is nothing but exchange of goods and services. So, you would exchange one set of goods for another set of goods. For example, the baker would provide bread to the fishermen in exchange of fish. And they used to count using their fingers. That's why the numbers from 1 to 9 are called digits. Remember, the fingers are also called digits. Because they counted on fingers, these were called digits. So the baker would say, I need one fish in exchange of one bread, right? So the fisherman would give one fish and the baker would give one bread in exchange of the fish. So that's how they used to trade in ancient times, right? Then of course the baker would say, okay, now I need two fishes, okay, in exchange of two breads. So the fisherman would give one more fish in exchange of one more bread from the baker, right? So these numbers came to be known as natural numbers because they came naturally to all of us. Basically, natural numbers are all the counting numbers, numbers used for counting or ordering. Okay. And the examples of natural numbers are very easy to understand. Okay. 1, 2, 3, 4, and all the way till infinity. Right. So all of these numbers are called natural numbers. Right. Now the baker demanded one more fish in exchange of one more bread. So he needed three now. So the fisherman gave him one more fish. But then the baker realized that he doesn't have any bread to exchange, right? So they felt the need to represent nothing because the baker was left with nothing. So the natural number did not have that facility. Okay, it started from one and it would go on to the higher numbers. So they introduced this concept of zero. They felt that we need to represent nothing with some number. So they put zero before one. And now they felt this represents the whole set of numbers. And that's why they started calling it the whole numbers. Whole numbers are nothing but the counting numbers, but including zero, right? So these are natural numbers as before, but we have to add zero to the natural numbers to get the whole numbers. So the baker has nothing to give, right? So baker says, I have no bread to offer you now. I have taken one fish, but I don't have any bread to offer you in exchange for that. So the fisherman says, no worries, okay? You now owe me one bread. So that brought in the concept of a deficit, which means the baker is in deficit of one bread. What does that mean? Even if he gets one bread, that's not his. He has to give it to the fisherman, right? Because he owes him one bread. So that introduced the concept of negative numbers. Negative numbers are numbers which are less than zero, okay, which represents a deficit. So for example, the baker has minus one bread now. What does that mean? Even if he gets one bread, okay, it's not his. He has to give it to the fisherman. So it's minus one. So it's a deficit basically. So negative numbers are minus one, minus two, minus three, okay, all the way till minus infinity, right? All these numbers that we saw so far came to be known as integers, okay? So that brings in the first classification of numbers. Numbers can be classified as integers. Integers in turn can be negative, zero, or positive. Let's take some example. Okay, positive numbers, as you know, are called natural numbers. Examples of negative numbers are minus 5, minus 10, minus 125. Examples of positive numbers are 8, 12, and 140, as you can see. The zero along with the positive numbers came to be known as the whole numbers, right? So that was one set of classification of numbers. They thought that, okay, we have classified numbers in its entirety until they encountered a very special problem. Okay, so let's go back to the original example. So the baker now again demands one fish in exchange of one bread, right? The only problem is when the fisherman gives him the fish, he realizes that it is not of the same size as the ones he had traded before, right? They were all big fishes. Now this one was a little fish. Now the baker felt that, okay, it is unfair to give one whole bread in exchange of this little fish, right? So he decides to give him only a part of the whole bread, okay? Something like that. Now that introduced this concept of decimal numbers, which means these are not whole numbers or entire number. Okay, these are numbers which also contain a fractional part. Okay, as you can see, the bread was a fractional of a bread. So these are numbers containing fractional part. Okay, you are all aware of decimal numbers, right? 0.5, 1.12, 6.45. And of course, we have negative numbers which can be decimals as well. Minus 0.75, minus 2.45. All of these are decimal numbers, right? So that gets one more branch to this classification of numbers. So we have integers on the left, and integers, remember, are those numbers which do not have any fractional part. We have the decimals now, right? The decimals are numbers which have a fractional part. So there's a fractional part in, okay, the decimal numbers. The decimal numbers can in turn be negative or positive. Okay, the examples are very easy to bring in. Okay, negative decimals are minus 6.3, minus 24.52, minus 530.7, and so on. Whereas the positive decimals are 7.8, 11.45, right? Well, now it feels like, okay, this is complete classification of numbers until, okay, recently they felt that numbers have to be classified into some other way. Why did they feel that need? Well, when they started dividing numbers into some parts, for example, dividing bread into different parts or dividing cattle into different parts. Okay, so the minute you start doing that, you would find that, okay, new problems would arise. For example, let's say we divide 1 pound equally amongst a few friends. Now, what's the big deal, right? You would say, okay, it can be done, no problem. Yes, of course, until you find that there would be no problem so far as the number of friends are a fixed number. For example, if the friends are 2, 4, 5, 8, 10, you would find that, okay, well, you can divide 1 pound into exact amounts. For example, if there are 2 friends, then each friend would get 0.5 pounds. If there were 4 friends, each friend would get 0.25 pounds. If there are 10 friends, each friend would get 0.1 pound. Right? So you can divide it into exact amount. However, if the number of friends are anything other than these values, then you would realize there's a problem. For example, if there were 3 friends, 1 pound divided into 3 friends won't give you an exact amount. It would be 0.33333. It's an infinite number of decimals. The same is the case with 6 friends, 7 friends, and 9 friends, as you can see. Right? So there are some divisions which give you these decimals, which are exact amount 0.5, 0.25, 0.2, and so on. Whereas there are some divisions which give you amounts that are not exact. Okay, they throw a infinite set of decimal digits like 0.333, 0.166, and so on. Right? Now, that brought us 2 more classifications, especially for decimal numbers. The ones on the left were called terminating decimals because the number of decimals terminated or stopped after a few decimal places. For example, 0.50 stop, okay? 0.25 stop, it stops there. Even 1 over 8, for instance, okay? The number of decimals stops after 3 decimal places, 0.125, stop, right? On the other hand, the numbers on the right, okay, were called non-terminating decimals or recurring decimals, okay? First of all, why non-terminating? Because the decimal places do not stop. They would go on and on and on. So they are non-terminating. Why recurring? Okay, what does recurring mean? Recurring means it repeats. So the number of the decimal digit, if you can see, it repeats. For example, in 1 over 3, 0.3, and the 3 repeats. Similarly, in 1 over 6, if you look at it, 0.16, the 6 repeats. Okay, even in 1 over 7, for instance, okay, you would realize it's 0.142857. And now these set of 5 decimal digits, 142857, keeps repeating, right? So they are non-terminating, but they are recurring, right? Now, how do we know when would we end up getting terminating decimals and when would we end up getting non-terminating decimals? Okay, that is an important thing, right? For that, we need to go and understand what is the number system that we use in everyday life. And that number system is called the decimal system. Now, what is the decimal system? Okay, if you look at any number in our system, like 5731, you would realize that I can divide this into set of place values. For example, 5 is in thousands place, so it is 5,000. 7 is in hundreds place, so it is 700. 3 is in tens place, so it is 30. And 1, as you know, is in units place or ones place, so it is 1. Now, why is it called decimal system? Because each of these place values can be expressed as some power of 10. What do you mean by power of 10? It is 10 raised to something. For example, 1000 is 10 cube. Okay, 10 times 10 times 10 is 1000. 100 is 10 squared, right? So 5000 is actually 5 times 10 cubed. 700 is 7 times 10 squared, and so on. So each of these place value can be expressed as some power of 10. Because of which, because 10 has only two prime factors, okay, which is 2 and 5. Remember, 10 is made up of only 2 and 5. What is it seen is any divisor, which is the denominator, if it only has factors 2 and 5, prime factors 2 and 5, like for example, numbers like 25, which only consists of 5, 5 squared. 125 consists only of 5, 5 cubed, right? 8 entirely consists of 2. 8 is 2 cubed, right? No other prime factor. Or there could be other numbers which contains only of 2 and 5, like 50 consists of only 2's and 5's, 2 into 5 squared. 100 is 2 squared and 5 squared, only consists of 2's and 5's, right? So any of these numbers which consist only of prime factors 2 and 5, if we divide by such numbers, then you will always get terminating decimals, because any of these place value can be exactly divided by these factors, right? So you get terminating decimals. In case of any other number, if you divide by any other numbers which has any other factor other than 2 and 5, let's say 3 or 7 or something, you get recurring decimals, right? So that brings us to three more classification. The first one is something which we are familiar with, okay? That happens when the numerator is an exact multiple of the denominator, right? For example, 42 over 7. Now, you know, 42 is a multiple of 7, okay? 7 times 6 is 42. So when you divide, you get 6. Likewise, 63 over 9 is 7. 78 over 6 is 13, okay? 132 over 11 is 12. Now, you're familiar with these numbers, right? We just saw that. These numbers do not contain any fractional part, and hence these are called integers. So when the numerator is an exact multiple of the denominator, you end up getting integers, right? The second category is when the denominators have prime factors only made up of 2's and 5's. Okay, this is something which we just saw. You'll end up getting terminating decimals, which means a decimal number which terminates after certain number of decimal places. 0.05, 5.375, as you can see. Okay, 1.28, it stops there. after 8, 23.7. So all of these are called terminating decimals. Remember, the rule for getting terminating decimal is the denominator or the divisor that you're dividing by should have a number consisting of only prime factors of 2s and 5s. Okay, no other prime factor other than 2 and 5. On the other hand, if we indeed have a prime factor other than 2 and 5 in the denominator, then you end up getting the recurring decimal, as you can see. Right? For example, 15, you can say, is consisting of 5 as a prime factor. So that should qualify as a terminating decimal. However, 15 also has 3 in it, right? Because of the 3, you end up getting the recurring decimal. So only if it entirely consists of 2s and 5s will you get terminating decimal. Any other prime factor apart from 2 and 5 will result in a recurring decimal. So it's non-terminating because the decimals do not terminate, but they recur, they repeat, right? Now, all of these numbers are called rational numbers. Okay, why rational numbers? Rational numbers are numbers which can be expressed as fractions. As you can see, all the numbers can be expressed as fractions. Okay, all of those can be expressed as fractions, and hence they are called rational numbers. Now, then you may wonder, okay, which are the numbers that cannot be expressed as fractions? Okay, the world did not know about it until a Greek philosopher named Pythagoras discovered such a number. Okay, he was experimenting with unit squares. Okay, unit square is nothing but a square with side 1 unit. And when he found the length of the diagonal, he realized that the length cannot be expressed as, okay, a normal number. Okay, you cannot write it in the form of a number or a fraction for that matter. Okay, so what's the length of the diagonal in this case? It would be square root of 1 squared plus 1 squared, which is square root of 2. Right? Now, square root of 2, if you find the value, you would realize that it is 1.414213 and so on. As you can see, okay, it's going on and on. It's not terminating, okay, it's unending, but neither is it repeating. If you look at it, any set of digits is not repeating. Okay, there's not a pattern which repeats. Another number which qualifies for this is pi. Okay, pi is a mathematical constant. Even the value of the pi, okay, it's non-stop, like it's never ending. Okay, 3.1415 and so on. Neither is there a set of digits which repeats. Okay, there's no pattern. So all of these numbers, okay, are non-terminating and non-recurring, right? And these are hence called irrational numbers because they behave irrationally, right? They do not behave rationally like any other numbers. They behave irrationally. Okay, these are numbers which cannot be expressed as fraction. Okay, you cannot express any of these numbers as fraction. Even though some might argue, okay, that pi is 22 over 7, but 22 over 7 is only an approximate value of pi. It is not the exact value of pi, right? So that brings us to the final classification of numbers, that into rational numbers and irrational numbers, right? Rational numbers are the numbers which can be expressed as fraction, whereas irrational numbers are numbers which cannot be expressed as fraction. As you know, rational numbers can be of 3 types. One is integers and decimals. Decimals in turn are of 2 types, okay, terminating and non-terminating, right? As you can say, integers are numbers which are the counting numbers, natural numbers and whole numbers, okay, which are do not have any fractional part to it. So 15 over 3 is 5, 80 over 4 is 20, and so on. Okay. As against that, decimals have fractional part, but terminating decimals have decimals which terminate after a fixed decimal places. When do we get that? When the denominator consists of only 2s and 5s as prime factors. Non-terminating but recurring decimals, the decimals do not terminate. Okay, they keep on going on. Okay. However, there's a pattern of digits which keeps on repeating. So they are recurring. When does that happen? When the denominator have prime factors which are apart from 2s and 5s. Okay, there should be at least one prime factor which is not a 2 or a 5. Right? That's when you get non-terminating but recurring. And finally, we did irrational numbers. These are numbers which cannot be expressed as fractions. These are non-terminating and non-recurring. Remember, they don't recur. Okay, examples of irrational numbers could be square root of 2, square root of 10, pi. In fact, all square roots of non-perfect squares are irrational. Okay, that's about it. Different types of numbers. I hope you understood the classification of numbers, the difference between an integer and a decimal number, and finally, you also must have understood what are rational numbers and irrational numbers. Thank you for joining in. Okay, have a good day.